Assalamu alaikum, dear students. Today we will discuss about the measurement of charge to mass ratio or charge to mass value of cathode rays. Students, you have discussed in the previous lecture that how we can calculate or how we can perform the experiment to discover the cathode rays. J. Thomson, along with Crookes, Faraday, and some other scientists, performed experiment in order to find the cathode rays, or in order to find canal rays, or in order to find neutrons. There are a number of experiments performed for the discovery, for the identification of subatomic particles. One of the particles was the cathode rays, later on known as electrons. We have discussed the discovery and properties of cathode rays or electrons in the previous class. Now, today we will discuss about the charge to mass ratio or the charge to mass value of the cathode rays. For this purpose, J. Thomson devised an instrument or devised a technique. J. Thomson in 1897 performed discharge tube experiment. He performed this experiment in order to find the charge to mass ratio of the cathode rays. Dear students, first of all, he performed the electric discharge tube experiment in which cathode rays were produced. Cathode rays produced will travel towards anode. He discovered cathode rays after emitting from the surface of cathode travel towards anode and strike on a point P1. He applied both electric field as well as magnetic field one by one in order to find the charge of a cathode ray. For this purpose, first of all, he applied a magnetic field. First of all, he applied a magnetic field. He applied a magnetic field perpendicular to the electric field. He applied magnetic field first, then he applied electric field. And after doing separate calculations or separate experiments, he applied both the fields simultaneously and measured the value of charge to mass ratio. First of all, he applied magnetic field having the strength of B naught or B is the beta is the strength of applied magnetic field. He applied magnetic field in the path of the cathode rays and observed that cathode rays moved with the velocity v, and the particle is a cathode ray or an electron. He found the strength of magnetic field as strength of magnetic field on a moving cathode ray or on a moving electron. We have read in the previous lecture that cathode rays were simply electrons. Cathode rays were simply electrons. That's why we can say that he applied magnetic field on an electron which moved with velocity v. Therefore, the strength of applied magnetic field will be equal to BeV. This is equation number 1. Here B is the strength of applied magnetic field, E is the moving charge or cathode ray, and V is the velocity with which the cathode ray or electron moves. Then, after the application of magnetic field, when the cathode rays entered in magnetic field, they started to bend their path downward direction towards the north pole of the magnet and rotated in a circular path from north towards south. When cathode rays moved or circulated in the circular path after the application of magnetic field, then there will be a force, which is centripetal force, which is needed to rotate a body in a circular path. So when he applied magnetic field on a moving charge, on a moving cathode ray, he observed the centripetal force as well, and the value of centripetal force will be equal to Fc will be equal to mv square divided by r. This is equation number 2. Then he observed all these changes and find the value of the velocity and charge to mass ratio of the particle. He found that by comparing equation number 1 and equation number 2, we will get BeV is equal to mv square divided by r. This v velocity is cancelled out with this v square. On rearranging this equation, we will get E remains here, m which is multiplied here, when comes here it will be divided, E over m will be equal to V over B will be shifted here, BR. Here is the B is the velocity of the moving electron or moving cathode ray, and B is the strength of applied magnetic field, and R is the radius of the circular path, radius of curvature. He found the strength of magnetic field, velocity and radius in order to find the charge to mass ratio of cathode rays or electrons. After doing this calculation, by applying magnetic field, he observed that cathode rays bent their path to the downward direction towards north pole, and from where it started rotation from north towards south pole, and found its E by m value. Then he applied electric field of strength E. Then he applied electric field of strength E on a moving charge or moving cathode ray, and observed that the strength of electric field will be EE. E is the strength of electric field and small e is the charge of an electron, or simply electron. Applied electric field on electron, and he observed that after entering electric field, cathode rays changed their path and moved towards the positive terminal of the applied electric circuit. From here he concluded that these rays traveled towards positive terminal of the battery and towards north pole of the magnet, so he concluded that they carry negative charge. Then he calculated charge to mass ratio by applying the electric as well as magnetic field simultaneously with their strengths equal to one another. After doing this work, he applied both the fields simultaneously. Then he applied both the fields simultaneously, in which the strength of electric field was equal to the strength of magnetic field, and he observed that when the strength of electric field EE is equal to the strength of magnetic field BeV, then he observed that cathode rays passed through these fields without any deflection and struck on the point P1. So from here we can put the value of BeV, or simply value of E by m. Now on rearranging This V will be cancelled out with this V, and we can find the value of V. V will be equal to E upon B. This is equation number 3. Now, by putting the values of V from equation 3 into equation A, we will get, by putting the value of equation 3 in equation A, we will get E over M is equal to E upon B into BR. So it will be E upon M is equal to E over B square into R. What is E? E is the charge of the cathode rays or charge of electron. M is the mass of cathode ray or mass of the electron. Capital E represents the strength of applied electric field, and B represents the strength of applied magnetic field, and R is the radius of the circular path. By knowing the radius of the circular path, he found the value of charge to mass ratio, and he calculated the value as 1.7588 into 10 raised to the power 11 coulombs per kilogram. This was the value of charge to mass ratio for an electron or cathode ray. Dear students, hopefully you have got the concept. For any query you can ask the question. Thank you so much. Allah Hafiz.